Welcome back, period 7. We're going to take a look at first going over just homework answers from yesterday's practice to make sure you guys are kind of getting the idea of it. The assignment to practice was actually less than what we covered in the notes. So really on these 8 problems, you just had to check if they were in standard form. If they aren't, rewrite them and then determine the degree of the polynomial. So good news is number 1, already in standard form. So we would go straight to saying the degree. Now a little reminder, the degree is the largest degree of your entire thing. So if x has a degree of 1, 3 is a degree of 0, this example would have a degree 1. On our second example, we can see here this is not quite in standard form yet. So if this is a degree 3, we have to rewrite this 5y to the third plus 4y squared plus 3y plus 1. And then we would go through and we would do the degree of the biggest term. So this would be degree 3. Third example, already in standard form. So we just need to label the degree here. The degree should be 2 because this one is a 2. Same thing over here. This is already in standard form. This is x squared, m to the first. So we have a degree 1, degree 2. So already in the correct order. So this would also be degree 2. As we move on to number 5, in standard form already, so we just take the largest exponent, so this would be degree 7. And then 6 is a little bit different because as we see, there is no variable. So anytime there is no variable, we call that a constant. We're really saying the degree is 0, but we have a more specific name for it as constant. On 7, this is not quite in the correct form yet. We can see this has a degree 3, so negative 3x to the third should come first, then our 2x squared, and then our plus 4x. After that, then we can tell the degree. The degree is going to be 3 because that's the degree of our largest term. Same thing with 8, we got to rewrite 8. So over here on 8, our largest term should actually be that negative x to the 11th, then plus 5x to the 4th. Then we go plus x to the 3rd, plus 3x squared, and plus x. And then again, once it's in standard form, the degree is just the degree of your first term. So this would be degree 11. Hopefully that made sense. We're going to talk a little bit more about how other ways that we can classify specific polynomials in our notes. So really just one more page of notes to get through for this section. And then you will have a short quiz on Canvas to kind of go over some of the stuff we talked about in our notes. So we're on 5.1 day 2 notes. It should have this table up on your note packet or your note sheets that you printed. So we're going to talk about something else today. We're going to be looking at a situation where we can actually use some function names for it. Now, we haven't done a ton of functions yet this year. The only functions we've spent a lot of time on are lines and exponential curves. So some of these will be a little bit different than what we've talked about. However, we have already talked about a constant. So a constant we say has a degree of 0, and that's going to be any numerical value with no variable. So an example could be something like 15, okay? So it's important that we just realize there is no variable. Okay? Linear is a specific function name we can give to any degree that is 1. So now we've talked about this before. We've seen equations in y equals mx plus b. Since we're only talking about expressions right now, we're really just focusing on this part of it. So any example that kind of looks like mx plus b. So that could be something like 2x minus 10 would be an example of linear. Quadratic. Quadratic is a degree of 2. So I could just add a squared term to this. I could say something like x squared plus 2x minus 10. And then we keep going from there. Cubic is going to be a degree of 3. I could add some sort of an x cubed term to this. Maybe 4x cubed plus x squared plus 2x. I could keep the minus 10 or I wouldn't need to either. those are the only kind of common function ones I'm going to hold you responsible for. Anything bigger, we're just going to label it by the nth degree, right? So we're just saying the degree is some unknown called n. And so an example could be something like x to the 9th plus 16x to the 4th, right? We would actually then go ahead and we will label that as the 9th degree. And I'm going to be abbreviating degree quite a bit for this section. Okay. Now, something really important to keep in mind when doing this, and you should have noticed this in our examples. In all my examples, notice in each one, it used the same variable throughout. I didn't have x's and y's. I only had one variable. Now, I could have used y's, I could have used m's, but I chose x's. So the really important thing when naming with a function name that I want you guys to kind of add to your notes here is that it can only use one variable throughout expression. And I'm going to abbreviate the word expression for you guys too. Okay, so again, I'm just going to recap that. So notice I can only use one variable throughout the expression if I want to use one of these names up here. So that would mean if I want to use linear, if I want to use quadratic, or if I want to use cubic. Okay, it can only have one variable. Let's take a look at some examples. Okay, and I'm going to kind of go slow through some of these because now we're going to label it with every way that we can. So when it says label the following polynomial and make sure it's in standard form. So we're always going to take care of standard form first. So here if we look at example A, 5x plus 15x squared, that is not in standard form. So we're going to rewrite that. That should be 15x squared plus 5x. Then we're going to label it. Okay, so now as we label this, now we have to pay attention to what I was just talking about. There is only x's used in the entire thing. So if there's only x's used, I can go back up and I can use one of these function names. So the function name that had a degree 2 was quadratic. So I'm going to come back down here and I'm going to name this now. This is going to be a quadratic. Instead of the degree, I'm going to put quadratic. And then we're going back to what we talked about yesterday about the number of terms it has. It has 2 terms, so this would be a quadratic binomial. Take a look at B. Okay, again, not quite in standard form. So we're going to rewrite this to be in standard form first. So I'm going to rewrite this. This should really go negative 6x to the 7th. Then it should be x to the 4th, because notice in our last term here, there is no variable. So that's really just a constant. So that's going to be our standard form. And then we do notice they're all x's, but we don't have anything for as big as 7. So when I name this one, this is going to be a 7th degree trinomial because it has 3 terms. Okay. Take a look at example C. Do we see any addition or subtraction in there? Nope. So this is just one term. Now, when we start to talk about the degrees, though, anytime you have more than one variable, we have to find the total degrees, which means we're going to add those together. This is really going to be an 8th degree monomial because there is no adding or subtracting. It is just one term. Okay. Take a look at D. On D, I'm going to slide this up a little bit. On D, we have to rewrite that. That's not quite in standard form yet. So this has a degree of 4 because we have to add those together. This has a degree of 2. So I need to rewrite this one. This one here would really be 15x squared, y squared, plus 2xy. If I want to talk about the degree, then I need to find the total degree of this one. So I'm going to add those together. So this would be a 4th degree binomial because it has 2 terms. Okay, let's take a look at the next one. Here, don't forget K actually has a 1 in here. So if I'm talking degrees, I need to add those together. So this would be a third degree monomial because it just has one term. There's no adding or subtracting. Okay. Now, some of you might be wondering, well, didn't we have a 3 up here in our list? We did, but we also have this rule that you can only use one variable. So the fact in this example that we use a K and an M, we cannot call it cubic. We just have to say third degree monomial. And then F, before we can do anything, we should notice again something we talked about yesterday. These are like terms. So when we have like terms, before we can classify, we have to combine those. So 17x plus 5x is going to give me 22x that I'm really talking about. Now the degree here is a 1. And since it's only using an x, I can actually use my specific function name and say this is a linear monomial from my function list up top. Okay. The last way I can kind of ask you about these problems is by asking you to give me an example. So instead of giving you an example and asking you to classify, kind of the reverse order of that. So let's talk through this first. So if I want an example of a cubic binomial, this word cubic means a lot of things actually for us. So first, it means that we want a degree 3, but it also means that we can only use one variable. Okay, so keep that in mind. Binomial means that our final answer needs to have 2 terms. So let's put that all together. So degree 3, only using one variable. So that could be something as like 2x to the third, and it has to be a binomial. So I could add 3 behind it if I wanted. Okay, lots of examples you could have for this one. This is just one example. Okay, here's another one. Quartic. Quartic actually means degree 4, and monomial means 1 term. So I won't test you on quartic. It's not on our sheet and our table at the top of the page. But quartic does mean degree 4 and a monomial is 1 term. So this could be something as simple as x to the 4th or any other variable that you would want to use. Okay. All right. Practice this stuff up on the rest of that page 1 assignment, and we will go over those answers in tomorrow's lesson.